Chapter 14, Transformations. Today we're going to cover section 14.2, Reflections. Our objective for today will be to locate images of figures by reflection. Reflection. A reflection in line M maps every point P to P prime such that if P is not on line M, then M is the perpendicular bisector of segment PP prime, and if P is on line M, then P prime is P. So this is really just a fancy way of saying the point is the same distance on the opposite side of the line. So if I look up here, let's call this first segment here AB. If I want to find the image of A, all I'm going to do is look at how far away is A from the line. It's 1 to the right. So A prime is just going to be 1 to the left. And then I do a similar thing looking for B. I notice that B is 4 units to the right, so B prime should be 4 units to the left. And I get a new segment then that looks like that. And if I notice the highlighted segment from A to A prime and the highlighted segment from B to B prime, that the red line is the perpendicular bisector of those two segments. Looking at an example for the one below, let's call this segment XY. Well, point X is right on the line, so if I go the same distance away, it's still going to be right on the line, which is why up above it says for number 2, if P is on the line, then P prime is the same as P, so in this case, X prime is the same exact spot. Now when I look for what happens to Y, well, Y is 1, 2, 3, 4, 5 to the left, so I go 1, 2, 3, 4, 5 to the right, and I get my new location for Y prime, and I can even draw in my segment. And I notice that the blue segment is also being bisected and perpendicular to the red line. Graph the reflection of the shape about the line. So over to the right, let's give some labels. Let's call this A, B, C, and D. And if I want to do the reflection, I'm really counting how far away from the line I am. So if I look at point A, I'm 5 above the line, so I should go 5 below the line to find A prime. And then go right around. Looking at point B is 3 above, so I need to go 3 below for B prime. C is 1 above, C prime is going to be 1 below. D is 1 above, D prime is going to be 1 below. And now I'll just connect them together to make my new shape. And I'll answer some questions. Are the distances the same? Well, if I look at all the figures from A to B and A prime to B prime, or B to C and B prime to C prime, all the distances are the same, so that's a yes. Are the angle measures the same? Well, the angles look like they're exactly the same from one figure to the other, so that's yes. Are the areas the same? Well, the figures look like they're congruent to one another, so the areas should be the same, so that's a yes. Is the orientation the same? To tell if the orientation is the same, I imagine if I just took this new figure and slid it up, could I match it up to the top shape and just sliding it around? I can't. Well, what if I took it and I tried rotating it? Could I try to rotate it to make it match up? And I can imagine if I try spinning it, there's no way I can get the shape to match up to how it was before. So the orientation is different. And I can sort of imagine that it's different just by bringing it down here, putting it sort of back to how it went. The big thing I notice is this. As I go from A, B, C, D up on the top, A, B, C, D, I'm going around in a clockwise direction. And if I look down below, A prime, B prime, C prime, D prime actually ends up going in a clockwise rotation. So I can't match them up. They actually rotate in opposite directions. So is the orientation the same? That one's going to be no. The last part. Invariant are those quantities that remain unchanged after a transformation. So for this problem, the ones that are invariant that remain unchanged, well, the areas are unchanged, the angle measures are unchanged, and the distances were unchanged. So those 3 quantities would have been invariant for the reflection. graph the reflection of the shape about the line. So I'm going to start by looking over here and labeling some points. I'm going to call this A, B, C. And I want to find A prime, B prime, C prime so that they're also the same distance away from the line. Well, I notice this line has a slope of 1. So when I start to make my measurements, I'm going to use the negative reciprocal, so I'm going perpendicular. So if the red line has a slope of 1, I'm going to count by using a slope of -1. So to find A prime, I'm going from A to the red line is a distance of 1. So from the red line to where A prime is will also be a distance of 1. So here's my A prime. Now to find the location of B prime, I'm going to go at a 45-degree angle here again. So to get from B to the red line, 1, 2, 3, 4. So I continue 1, 2, 3, 4 in the opposite direction. And now I've found where B prime is at. And doing a similar thing, counting for the C value. So C is 1.5 from the red line. So if I go 1.5 again, I end up at C prime. And then I can just connect them together. So A prime to B prime to C prime, and then back to A prime. So there's my new triangle